All right, exam 2 is on Tuesday. The 11th. The day after my 13th anniversary. Wow. I haven't made it yet.
13 years, I'm sorry.
And the topics are all the old stuff. And vectors. And 2D kinematics of particles. Anyone have any questions about? So to get ready for the test, your goal is, to get ready for the test, you need to do the practice problems, and you need to know them really well. And you know you're ready for the test when you get to the point with all those practice problems that you can do them, and you could also explain why you're making each decision. Okay, so you're not just memorizing the solutions. You need to know why you had to do. Why was this positive? Why was this up? Why was this negative? Why is this? Why do we know this component and not this one? If you understand why the decisions are made in those problems, you'll do great in the test. Anybody have any questions about the test itself? And we, right at the end of last class, we moved on to the next stuff that's not going to be on the test. So if you have any questions about, want me to explain any practice problems or anything, I'd be happy to do that as long as you want today. And then when you're done with that, we'll go back to the new stuff. Yep.
So with the cumulative, I mean, all the problems kind of like build on each other. So by that, do you mean we might have a similar problem as like we did from last
Yes, that's right. So there will be problems like the practice problems on 1D kinematics, and you'll have to know how to do unit conversions and stuff. Like all of that stuff, you need to refresh your memory. I don't remember if I said this to this class, but I think a good way to approach looking at the old problems is to go through them, look at the question, see if you can think of how you would approach doing it. If it pops right to your mind and you know just how to go about it, then you're probably good on that one. Move on to the next one. Wait till you get to some problems that you don't remember how to do and work through those. You know, I think that's a good way to approach the old ones, because you probably don't have time at this point to, work through every practice problem all the way through again. But if you do, that would be helpful, Anybody have any practice problems you'd like me to do? Yep. Like the lab? Yeah, that kind of stuff will not be on there. It'll just be like the posted practice problems on D2L. The stuff like we did in lab is the kind of stuff that's going to be on the lab test, whenever that is in a couple weeks. Okay. Any questions? Yep.
Can we go through like a problem, like 2D kinematics?
Sure. You want me to make up a new one? Okay.
Yeah.
Okay. Yeah, maybe I'll put it up and I'll give you some time to work through it, and then I'll do it after you have some time to think about it, okay? I don't know how many. It depends what kind of questions they are, but all of these tests, when I write them, they're intended to be an hour long.
Okay.
So you should have time to, like if you make a wrong start on something and have to go back, it shouldn't be that big a problem. Okay, let's say that that's a car. Let's say it's driving this way at 20 meters per second. And an object is dropped out of the window. From a height of 1.5 meters. How far does the object travel horizontally? Before it hits the ground. And second, what's the object's velocity vector? The instant before it hits the ground. Okay, so let's take a few minutes and try to work through this together. And if you get stuck, you can ask me questions. And then after you've worked on it for a while, after most people are done, I'll go through it and you can compare your work to my solution. So, first we have to choose those four things. Time equals 0, time final, origin location, and the coordinate system. Time equals 0 is when it's dropped. Time final is when it hits the ground. The origin, you have flexibility with this, but I'm going to do what I usually do, put it on the ground, beneath the point where it's dropped. And then the coordinate system, I'm going to put the coordinate system I'm going to put on the ground with the y-axis up and the x-axis horizontal in the direction of motion.
Can I ask
Yes.
something? So for the origin, can you say like at the location of the time equals 0? Or
Yes, exactly. So it's on the ground beneath the object's location when time equals 0. Yep, that's a good way to think about it. And then let's list out what we know and want. Do we know time final? No. Do we know acceleration? Yes. So AX is 0, AY is negative 9.81. Do we know P initial? What's PIX? PIX is 0. What's PIY? Right. Do we know anything about P final?
P final Y.
Right. P final Y is 0. And we're looking for PFX. So that's what we want. Do we know initial velocity?
Yes.
We can figure that out. So the way to figure that out is we know that the velocity vector at time equals 0 is horizontal with a magnitude of 20 meters per second. I'll just write it 20. So that's the vector, and we need to come up with the components for that vector. And anytime you're trying to come up with vector components, you put the tail of the vector at the origin, and then come up with that counterclockwise angle. But one thing you might notice, anytime you have vectors that are aligned with the coordinate axes, remember coming up with vector components is the same thing as coming up with the coordinates of the head. So what are the coordinates where the head of this vector is? It's all along the x-axis in the positive x direction. So it's going to be positive 20 for an x coordinate and 0 for a y component, for a y coordinate. And so those are also the components of that vector. If you don't see that, you can use 20 times cosine of 0, 20 times sine of 0. But that saves you a little time. So Vix is 20, Viy is 0. Do we know anything about the final velocity? Nope. Okay. Is there any equation that works that has this in it and anything else in it appears here? Yeah, right. So nothing works, so we need to find TF. So what equation is going to let us find TF? We're actually going to have to use the y equation to find TF. So PFY is equal to PIY plus VIY TF plus 1/2 AY TF squared. So 0 is equal to 1.5 plus 0 minus 4.905 TF squared. You could use the quadratic formula to solve this, but if you notice it, you can just move one thing to the other side and just use square root. So 4.905 TF squared is equal to 1.5. And so TF squared is 1.5 divided by 4.905. That's TF, 0.306. Okay, so TF, oh, that's T squared? Okay. Okay, so this is 0.306, and so take the square root, and you get plus or minus 0.55, did you say? Plus or minus 0.55 seconds. This is time, so we have to take the positive one. And now that we have the time, we can plug it into the x equation. So we're going to use this equation. PFX is equal to PIX plus VIX TF plus 1/2 AX TF squared. So PFX is equal to 0 plus 20 times 0.55 plus 0, and I think you get 11 meters. Any questions about that part? And then for part B, we're trying to figure out the velocity vector when it hits the ground. Is there any reason to change any of these things? Nope. So we'll just keep all these the same. And whenever you do that, that means all the values that you knew before are still the values. So we calculated TF. So now we know TF is 0.55. We still know the acceleration. We still know the initial position. Now we know everything about the final position. PFX is 11, and PFY is 0. The initial velocity, VIX, is 20, and VIY is 0. And what we want is the final velocity, so we want VFX and VFY. And we're just going to do those one at a time. So for the x component, VFX is equal to 20 plus 0 times TF. This is the VF equals VI plus ATF. And so you get 20 meters per second, which is, that's just always the theme in any kind of free fall motion. The x component of the velocity doesn't change over time. The only thing in free fall, the only thing when something's dropped or launched or whatever that makes the x component of velocity change is air resistance. And if you ignore that, the velocity stays the same. And the y component is 0. Minus 9.81 times 0.55. And what do you get for that? Negative 5.39. Okay. And so to write it as a vector, the final velocity vector is 20x negative 5.39y. So now let's think about how much sense this makes. Do you think the answer is going to be none or some?
Some.
That's correct. It will make some sense. So if you think of plotting the, no, don't think of it like this. Okay, so let's think about the motion. So the object is dropped up here. It starts out horizontal and then follows a parabolic path like that. So right before it hits the ground, The velocity vector is pointed that direction. And now to come up with the components for that velocity, think of putting the tail of that vector at the origin of the coordinate system. And remember that the components of this vector are the coordinates of the head of the vector. So what's the sign of the x-coordinate of that point? The x-coordinate is positive. It's in the positive x direction. And then what's the sign of the y-coordinate? Negative. And that's what we got in our answer. Question? No. That's just to try to sort of help you picture what's happening.
So like
Yes.
it's if you want to just find the regular velocity,
Mhm.
it's just the hypotenuse, right? So it'd be that 20 squared.
If you wanted to find the speed, you mean?
The speed.
That's right, the hypotenuse. So you'd use Pythagorean theorem for that. That's right. So it's going to be something more than it will have sped up, and the amount it sped up is just from how much it drops. As things are dropping, they're speeding up. Any other questions about that one? Anyone want to do another one? Yes?
Can we do a vector one? We do a lot of helicopter.
Yeah, I like it. Okay, so you got a sick sense of humor. Okay, so okay, so let's say this helicopter is moving at a 45-degree angle. With a speed of 10 meters per second. And it drops an object from 20 meters above the ground. So first, what's the height of the object at its highest point? Yep. And second, how far will the object travel horizontally before it hits the ground? No, the object is just dropped, but that's how fast the helicopter is going when it's dropped.
Is A intention? You already told us how high.
Okay, so this is sort of an interesting thing. So remember the initial velocity of the object, the velocity of the object when it's dropped is going to be the same as the velocity of what it's dropped from. Okay, so the fact that it's dropped from 20 meters above the ground You think if you drop something from 20 meters above the ground, it just goes straight down. But this thing is going to be moving at 10 meters per second at 45 degrees, which is exactly the same as if instead of being dropped from a helicopter, this thing was just thrown from something stationary at 10 meters per second at an angle of 45 degrees. So even though it's dropped, the velocity from the helicopter is going to make it take off at 45 degrees at 10 meters per second. And so it is actually going to go up a little bit before it reaches its highest point and then starts coming down.
Are there going to be ones like that on the test? Or are you going to tell us that?
No. There might be ones like that on the test, and I will not tell you that.
So basically what you're saying is it's exactly like shooting it.
Yes, it's exactly like shooting it at 10 meters per second, 45 degrees above horizontal. Yep. This is pretty similar to the helicopter practice problem, I think. It asked the same question, I think. All right, so for part A, we're looking for something at the highest point. So time final is going to be when it has to be when it reaches the highest point. Time equals 0 is when it's dropped. Time final is when it reaches the highest point. The origin, I'm going to put on the ground. Beneath the object's location at time equals 0, which is the same thing as saying beneath the drop point. And then the coordinate system has the y-axis up and the x-axis horizontal in the direction of motion. Do we know time final? No. Acceleration, we know. Do we know anything about the initial position? Yeah, PIX is 0 because the origin is right underneath. And PIY is, was it 20? And then, do we know anything about the initial velocity? Yeah, we know both of those. We have to use cosine and sine to get those. We know that the initial velocity is 10 meters per second at an angle of 45 degrees. And so to get from the positive x-axis to this vector is positive 45. And so that velocity vector is 10 times the cosine of 45 degrees, 10 times the sine of 45 degrees. And that's 7.07, 7.07. Do we know anything about the final velocity? I keep skipping the final position. Yeah, so we want to calculate PFY. I skipped that. And then, yeah, final velocity. What we know, like anytime you hear highest point, that should trigger in your brain that you're going to have to use the fact that V final is equal to 0. The y component of V final. VFY is equal to 0. We don't know anything about VFX. Well, secretly we do. Deep down we do know that the final x velocity is going to stay the same as the initial x velocity, but we don't use that in the equations. Okay, that's everything. Is there an equation that works? Yes.
I just have a question about what you just said.
Mhm.
So the final, the x velocity stays the same because the acceleration in that x direction is zero. Right?
That's right. That's exactly right. Yes, exactly. So 2ay times the quantity pfy minus piy is equal to vfy squared minus viy squared. So if you multiply these two together, you get negative 19.62 times pfy minus 20 is equal to 0 minus VIY is 7.07 squared. And so negative 19.62 is equal to 392.4 minus 50. This should have a PFY.
Yeah, 49.9.
And this is negative. So negative 19.62 PFY is equal to negative 442.4. And now you can divide both sides by negative 19.62. And what do you get? 22.55 meters. So before it starts coming down, it goes up 2.55 more meters because of that velocity of the helicopter. Any?
Yeah, how did you, I'm sorry, could you
Yep.
just explain between lines 2 and 3 of
Yes.
the equation, how did you get negative 392.4 and negative 50?
Okay, so
It's rounded for the 7.07.
negative 19.62 PFY plus 392. So I distributed the negative 19.62 through both of these. Is equal to, and 7.07 squared is 50.
But you don't have to do it that way. Yeah, I got the same answer as you were.
Okay. If you got the right answer, then what you did worked. Any other questions about that one? And then for part B, we have to change things. Yes, that's what I was going to ask. Dang it, I really wanted to ask. Okay, so time equals 0, time final, origin, coordinate system. Time equals 0. Is there any reason to change that? Nope. Time final? Yes. That has to be when it hits the ground. And then these two can stay the same. And so of the values that we knew before, what values are going to stay the same? All of the initial stuff is going to stay the same. All of the final stuff is going to change. Okay? So time final, what are we trying to find? How far it'll travel. Okay, so time final, we don't know. For now, we don't think we care. Our opinion might change. Acceleration, we know because it's free fall. Initial position, PIX is 0, PIY is 20. P final, it's hitting the ground, and the origin is on the ground, so PFY has to be equal to 0. And we're trying to find PFX. Initial velocity, VIX is 7.07. VIY is 7.07. And then we don't know anything about the final velocity. Well, really we do, but we're not going to use it in the equations. What do we really know? We know VFX is 7.07. That'll never change. Okay, is there an equation that works? I think, yeah, we need TF. So we'll use the equation that says PFY is equal to PIY plus VIYTF plus 1/2 AYTF squared. So 0 is equal to 20 plus 7.07 TF minus 4.905 TF squared. How do we solve that? Quadratic formula, yep. So this is A, this is B, and this is C. And can someone punch that in for me? Okay. Okay, so these are the two answers. Time can only be positive, so we'll take this one. We don't want this one. And now we can use that in the x position equation. PFX is equal to PIX plus VIXTF plus 1/2 AX TF squared. So PFX is equal to 0 plus 7.07 times 2.86 plus 0. And what do you get for that? 20.22 meters. Any questions about that? Okay, let's call it a day. So, test on Tuesday.